AB is a diameter of the circle ABC with center 0. AD is a tangent to the circle at A, and angle ABC is equal to 40 degrees. Calculate angle BAC. So first of all, let us highlight this angle. So we have the following. We have B, we have A, and we have C. All right. And so we have this triangle that we're zeroing in on. So this is the triangle that we're looking at. And so we need to figure out what is the size or what is the measure of angle A, all right, in this triangle, all right? And so what we have here is this is the angle that we're looking for. This is the same one right now. All right, this is the angle that we're looking for. And so our goal is to calculate the size or the measure of this angle BAC, the same angle that is in red. Now, how are we gonna do this? Well, what do we know already? Well, we know that this is 40 degrees. But do we know what is this angle C? Well, we can use this theorem, and the theorem states the following. The angle in a semicircle is 90 degrees. Notice the diagram that we have. We have the diameter AB, and this diameter cuts the circle into two halves, right? This half and also this half. So this is a semicircle. And notice that this angle, angle C, is 90 degrees because the angle in a semicircle is 90 degrees. In a similar manner, we have the diameter BA, which cuts the circle into two halves. This half, right? This is a semicircle. And then this half, this is also a semicircle, right? And this angle, angle C right here, is 90 degrees because the angle in a semicircle is 90 degrees. And so based on the angles, based on this theorem, right, we know that this angle right here, angle C, is 90 degrees, all right? So we know that this is 90 degrees. Okay, seeing that this is 90 degrees, well, what can we do? Well, this is 90 degrees, this is 40 degrees, and this is the missing angle. And we also know that angles inside a triangle add up to 180 degrees. So that means that 90 plus angle A plus, that means that 90 plus 40 plus angle A must add up to, these three angles must add up to 180 degrees. And so if that's the case, we are going to add 90 and 40 and take that sum and subtract it from 180 degrees. And that's going to give us the size of angle A. And so that's what we do. So we say 180 degrees minus 90 plus 40. 90 plus 40 is 130. So we have 180 minus 130, which gives us 50 degrees. And so that means that this angle, angle A, is 50 degrees. Next, our goal is to determine the size of angle CAD. CAD. So let's highlight that angle, angle CAD. Just highlight that angle. So we have C, A, and D. All right. So this is what we're looking at, right? Angle CAD. And so this is the angle. Let's use a red color. This is the angle that is right here. So this is the angle that we're looking for, right? And so we need to figure out the size or the measure of this particular angle. Now, in order to do this, we're going to use a particular theorem, and the theorem is headed as the alternate segment theorem. And what does the alternate segment theorem state? Well, the alternate segment theorem states that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. So what does that mean? Notice that we have here a chord, right? The chord is AC, that's a chord. And then we have this tangent, right? And so this angle, right? In fact, let's use the diagram first, right? Before we get to this diagram, let's use this diagram. So we have this chord, right? This chord is AC, right? And we have this black line, which is the tangent. And so what this theorem is telling us is that this angle that lies between, this angle theta that lies between the chord AC and the tangent is going to be equal to this angle that is subtended by the same, this angle that is subtended by the same chord in green. So what does that mean? That means that this angle and this angle, they are equal, all right? So this angle that lies between the tangent and the chord is going to be equal to this angle that is subtended by the same chord in the alternate segment. And so if we were to go on our diagram now, we have a tangent line and we have a chord and we have an angle that is between the tangent line and the chord. And so based on the alternate segment theorem, we know that this angle right here is going to be equal to this angle because this angle is subtended by the same chord in the alternate segment. And so what does that mean? That means that this angle is, since this angle is 40 degrees, this angle must also be 40 degrees. And we know that this angle is subtended by the same chord because if we look carefully, right? If we notice carefully that this angle right here that measures 40 degrees, the legs of this angle rests on this chord. And so that means that this angle here is subtended by the same chord that we have in yellow. All right, and so that means that if this is 40 degrees, all right, this must also be 40 degrees as well. And so that means that the angle A is going to be equal to 40 degrees. And why 40 degrees? Because of the alternate segment theorem. And that's our answer to this question.